Hello, my name is Bakri Dasuki, physics teacher. I'm gonna be your teacher for the lesson of today. For the students who are in level IGCSE 2, today we're gonna take Unit 8, Electricity. As you can see, we finished 8.123, now we're gonna today start with 4. As you can see here in the book, page 171. 0.8 electricity. So today we're gonna start with page 178, as you can see, okay, with current in simple circuit. So let's talk what is the current in simple circuits. For example, here we have a battery or a cell that gives us electrons, okay? So the electrons, because of the chemical interaction between the cell, so as a battery, for example, it gives us electrons. So the electrons is flow including the connecting wire, okay? For example, in this circuit. So the thing here is we have a switch, but it's now still connecting. Nothing happens. So electrons are going down. Okay, connecting, depending from the connecting wire from the negative pole to the positive. But here we have a lamp and we have a filament, very thin filament wire. Probably it's made from tungsten. So when it's coming there in, what happened to the lamp? It's glowing. Okay, and the electrons will continue to the cell and they keep doing that. So now question, why is the lamp is glowing? Okay, the lamp is glowing because there's a huge amount of electrons are flow inside the filament that make it glow, and that make the lamp turn on. So how am I gonna turn it off? Even if I move the cell so there is no electrons, here we have the switch. So the switch is it's even two sides, even on or off. Okay? So if it's on, it's connecting for connecting wire. But if it's off, here it's cut the connecting wire. If you look close to the switch, will be like this. So, or the symbol for the switch, so it won't be connecting. So the thing is, what will happen? The lamp will be turned off. Why? Because the switch is open. So we don't have any circuit without it. It's all connected from the negative to the positive pole. So the thing is, for the switch, it has also, like we say, should be really connected. So it give us the glowing for the lamp. Okay? As this is example, every one of your room have a lamp. As you can see, here is the lamp. So this is the switch. As I'm holding this is switch. Okay? And here is the lamp. So the lamp now have a generator we have electricity from the generator until here. So in this case, the generator is the cell that gives the electrons. So the electrons coming for this switch and this connecting, this is the switch, and the lamp here is this lamp. So watch with me, when I cut the switch, it's turned off. When I switch it on, it's turned on. Okay? So you already use this example in each day, literally in your daily life. So also there's circuit symbols, as you can see here. This symbol is for the cell. Okay? This for connecting wire can be copper. Usually most of the time it's copper or aluminum. Here is the switch. Here is the lamp. And here is the ammeter. So how we can draw this in the symbols? Can put the cell, then the switch, then the lamp, then you go with the connecting wires. So you have to be always notice that the long one is what is the positive pole, like you can see here, and the short one is the negative, where the electrons is moving. Okay, clear? Now we move along with something measuring current. Now this current, as we say, it's what? It's flowing here, right? So how I can measure this current? So the current is what? It's a flow of high charge, and it's about 6 million electron per second. So that's actually a lot of amount. So the measuring current is in ampere, and the French scientist André Ampère, who find this out. So we don't use this amount usually for the small calculation. So we divide it to 1000, so milliampere. So each 1 ampere is 1000 milliampere. Okay? So the more current we have, more ampere, that means what? More flow of charge. Okay? So more flow of charge, that means more current, as you can see here. So we get back to ampere for this circuit. So how I can measure that? Thing is, there's ammeter. We're gonna put it here after the load, and it's gonna give us what? The load. So this ammeter effect, the circuit, no, it's almost not affected, so don't take that much thing to measure. So it's almost don't change the result that take it for the lamp. Okay? So this like some typical current values for the touch lamp is 0.8 ampere, that means it's what? Including to this, it's 0.2, that means 200 milliampere, or 0.8 with 0.2 ampere. And the charge light, the car headlight lamp, it's 4 ampere, and the electric kettle is 10 ampere, as you can see here. So we're talking about the charge. The charge is in what? It's column. Okay? So the charge is the current in time. So every second, with 1 ampere that it passes 6 million electron, it's 1 coulomb. Okay? So for example, of course the current is ampere, the charge is coulomb as we see, and the time for sure is second. So a simple example, if we have 3 ampere, okay, current, it's passed by for 2 seconds. How much is the charge? As we did with the law, charge is current in time. So charge is 3 ampere in 2 seconds. Charge is 6 coulomb. Okay? And go on. Now we go to the current direction. So conventionally they say that current is going from the positive to the negative. But actually, the electrons are moving from the negative to the positive. That's why it's the electron direction. Okay? But now we want to try to measure if we have something, if we have 2 emitters, and here is in the same mode. Does each emitter give us different reading? Actually no, it don't. Each emitter, if they are in the same circuit and they are in one load, they give us one read. So this ammeter, for example, is 2 ampere, and this will be 2 ampere, including to this circuit. Okay.